So hello my friends, my name is Tulen Thapa and today I will be teaching you about sorry I forgot my intro. My name is Tulen Thapa. I am studying pursuing the course BSc Honors Physics in Ramjas College, Delhi University, and today I will be teaching you about potential well. So I have newly got a laptop, so I'm trying to do everything so that I could make some money. Let's forget about the things and let's focus on the potential well system problem or system. Simply, I will take it very simply, make it very simple. Here, potential is equal to infinite. Here, potential is equal to zero, and here, potential is equal to infinite. Hence, a particle here, if the particle is here, he cannot go here, and he cannot go here. Simply, I am trying to say that if a particle is placed inside this potential, inside these two, x is equal to 0 and x is equal to a, then it cannot escape simply by any means to here because there is infinite potential and it will take much force, much energy to go there. And also these walls are rigid and impenetrable, simply rigid and impenetrable. And also we have to take an assumption that when the particle or the material wave or the matter wave or anything that collides with this wall, these walls, they get knocked back or they get right into back into the system without getting or loss without loss of any energy. Simply, that we can simply say that it is elastic collision. So now I will be teaching you about how to find the eigenvalues, energy eigenvalues, and the eigenfunctions, which is the main question asked for everyone. But I will tell you something. I will tell you simply so that you don't have to worry about anything that much. Oh, so simply we have to use always in any type of system we generally use Schrodinger time independent wave equation, because if we take time into consideration, it will be very hectic and we would not be able to solve anything. And also this is one dimensional, so that it is more simple for us. And now we will get into it. So simply, I can say that the wave function. So firstly, we simply have to take the Schrodinger wave equation. है ना? We have to find a wave function from Schrodinger wave equation. So we have to take Schrodinger time independent wave equation in potential well in potential barrier. Everywhere we have generally used time independent wave equation Schrodinger, which I have personally found it out. Mm. So we will use this equation del square upon del x square phi plus, this is a Schrodinger time independent wave equation, and we can, here we have 2m upon h bar ka square e minus v, and it is phi is equal to 0. Now if we see here that in first we have phi is equal to infinity, and second we have phi into infinity, and we have to see only in the third region. So in the third region we have to generally see what is happening in the third region, because first and second there are no particles or material particles, because v is equal to infinity. So in the third region we have v is equal to 0. So this Schrodinger wave equation simply converges to del square upon del x square plus 2 upon h bar ka square. Simply we have, it is very simple, but just we have to take into look into consideration this. So we have this equation, and this is nothing but differential equation of second order. Mm, so now we can write del square upon del phi upon del x square plus k1 phi is equal to 0. Simply I have put k1 is equal to under root 2mb upon h bar, है ना? So we can simply, why we have put an k1 is equal to, and here it is k1 का square. So now k1 का square is equal to 2m upon h bar का square e, simply 2m upon h bar का square upon h bar का square into e. Simply now why we have put k1 is equal to this. So now it has simple, very simple theory. K1 is equal to p square, no, sorry, k1 is the wave number, so 2 pi upon simply lambda, and lambda is equal to h upon p, है ना? So h upon p will go upside, and this term is h bar, so we have p upon h bar, and we all know that what is p. P square is equal to p square upon 2m is equal to energy, so kinetic energy. So So what will be P? P is equal to 2 me upon h bar. Simply we have this formula. If we have not learned this formula, you have to write it. You should try to learn it. P square upon 2m is equal to P square upon 2m is equal to I for kinetic energy or E simply 2 me upon h bar. So we have put it. Now this equation we have to find a solution using mathematics that which we have not to do or not have to show in the physics paper. So simply we all people generally learn this answer of this wave equation or solution of this wave equation which gives a wave function. So so this can be solved using differential equations of second order methods and general solution, and we have general solutions, and we have general, and I don't remember it, but we have general and one more solution type of solution we have learned in mathematics. But I have learned it in GE, matlab general related subject. So generally BSc honors student physics learn it much faster than BSc honors physics students. So let's get into it. So our function would be a cos k a sin k1x, a sin kx, a sin k1x. Sorry. Yeah, we can simply write phi is equal to a sin k1x. This is the solution we get after solving it using mathematical terms, mathematical processes. This is the term we get. So now we simply have to put in the boundary condition. So at x is equal to 0, we have phi is equal to 0. Boundary condition we can simply see from the boundary. At x is equal to 0, phi is equal to 0. Simply we have this boundary, and at x is equal to a also we have phi is equal to 0. So now we have phi is equal to a sin k1x will be 10 to 0. So we have, and we put phi is equal to 0. So we have sin 0 is equal to 0. So this time will be 0. And we have b cos k1 into 0. So it will have 1 cos 0 is 1. So this term is 1 and b will come out to be 0. So by applying this boundary condition, we have our wave function. We have our wave function a sin kx k1x, a sin k1x. Now we put the boundary condition phi is equal to 0 at x is equal to a. So now we have sin k1 into a, sin k1 into a capital A here, and it is equal to 0. Now we cannot put a is equal to 0 because here if we put a is equal to 0, then the wave function would vanish and we will have nothing to work with it. And if wave function vanishes, phi square vanishes and psi square vanishes, then the probability of finding the particle inside the box vanishes. But when I have to tell you that psi square is the probability of finding the particle inside particle, है ना? So if psi vanishes, psi square is equal to 0. So if psi square is equal to 0, that means there is no particle inside the potential well, but we have found it that there is a particle inside the potential well. So if we take into this into account, so sin k1x is k1a will be equal to 0. And sin k1a equal to 0 means that sin k1a is equal to 0 means that sin k1a is equal to means that k1 n pi. Sorry, I have said it too many times. Simply n pi, because sin n pi is equal to 0. So we can find the value of k1 as n pi upon a. We found the value of n pi k1 is equal to n pi upon a. Now if we put the value of k as 2me upon, we have h cut is equal to n pi upon a. Squaring both the sides, we have 2 का square 2 me, this is under root under upon under root. This was on the upon in inside under root, so it will not function have any effect. We simply put it outside the under root, and here we have n का square pi का square upon a का square. Now we find the value of energy, so we have n का square pi का square h bar का square upon 2m a का square. This is the energy eigenvalues, and how this is energy eigenvalues and not energy eigenvalue is because we have this n term. where n can tend to 1 comma 2 comma 3, and now n cannot be 0, because if n is equal to 0, then there will be no k, I suppose, है ना. Then there will be no k. If n is equal to 0, then there will be no k. There will be no k, मतलब there will be no potential, no kinetic energy, no k1. So there is, if there is no k, so there is, this will be tend to 0, and again this wave function would tend to 0. Or simply if the particle would have some kinetic energy or have some potential k, sorry, wave number k means potential, मतलब may have some momentum in it. If momentum tends to 0, so that means, no, I am little confused, but k cannot tend to 0, because if momentum is, the momentum can tends to 0. Uh, how can I explain this? Simply, matlab, if k1 tends to 0, so again here sin k1, sin k0 is equal to 0. So if k1 tends to 0, so we would have not have, we would not, oh, no, that's analogy is little bit weird. So I will think of it somehow and tell you about it in next lecture. So we have energy eigenvalues here. Now for eigenvalues or for eigenfunctions, we have our function as phi is equal to a k1 a sine k1x. We can put the value of a sine k1 as a sine and pi upon a into x. Now we have to normalize this wave function. So we write n into n का square into a sine n pi upon a x का, this will be square and this will be square, is equal to 1 dx minus infinity to 0 to infinity. This is the normalization condition. In normalization condition, we have when the wave function is normalized, we have psi star dx is equal to 1. Psi star can also be written as mod of psi ka square. And if we have to find a vector that is with that one multiplied by this, I find the scalar that one multiplied by this term constant simply, we get 1. So we write n into n. So this is n ka square. From here it comes. So simply we have to integrate this, and after integrating this, it has simple integration. Simply 0 to infinity. N ka square is outside the bracket and 1, and here it is. What was here? A का square, I suppose a का square sine square and pi upon a, and here we have dx, I suppose, and pi upon a into x. So now we have n का square, and we can write a का square outside the bracket, and we have 1 0 to infinity, and we can write this as 1 minus 2 cos 1 minus cos 2x, है ना, 1 minus cos 2h 2 n pi upon a into x upon 2. We have simply used the formula of cos 2x. देखो cos square 1 minus 2 sin square x is equal to cos 2x. So we have 1 minus cos 2x upon 2 is equal to sin square x is equal to 1. So now 1 by 2 is n square a square. Now if we put 0 to a as the limit, because we have to go from 0 to a only, check from 0 to a only simply. So we will have 0 to a 1 by 2 dx minus cos 2 n pi upon a x cos 2 n pi upon a x into, and it is integration, and it is dx. So it will come out to be, here it will be a by 2, because x and a है ना simply. So we have n square upon n square into a square a by 2 plus, or simply minus, we have sine integration only, cos integration will be minus sin x. So sin n pi x upon a 0 to a. And now if we put the limits, this will term will tend to 0, and we have n square a by 2 is equal to 1. So n is equal to under root 2 upon a. Just wait a second, I am seeing that if I have done anything wrong. No, I have done nothing wrong. So we simply have n is equal to this, or n a n ka square is equal to this. No, two upon a. Now we can simply neglect this n ka square. I have taken this for making you understand that what we have to do. So we can write n ka square value can be 1. So we can simply find the value of a square is equal to 2 upon a. So a would be root 2 upon a. And now we put the value, we have eigenvalue function as root 2, eigenfunction as root 2 upon a sine k1a sine k1 n pi upon a into x. So this is the eigenfunctions. Here we put to n is equal to 1, 2, 3, and we get the eigenvalue functions. Minimum eigenenergy or minimum 0 point energy is for n is equal to 1, and for we have eigenfunction we have n from n is equal to 1 only. Simply n by nx upon a. We cannot put n is equal to 0 because again it will tend to 0, and we will have no wave function simply. Thank you, and I have stumbled upon many times in this video because it is very late at night and tomorrow I have a paper of this subject only, so I thought it would be nice to give it to you some tips for your paper. Thank you, and you do also well in your paper. And I want to share something. I have not been eating well for many days. If anybody is up to here, have fun knowing this. So thank you.